Hello, my name is Scott Walker. I am a senior oil and gas engineer with the Division of Oil, Gas, and Geothermal Resources, otherwise known as DOGGR. DOGGR is part of the Department of Conservation. I am a registered professional engineer licensed by the state of California. I have 30 years experience including expertise in drilling, production, and reservoir engineering. Because of my technical background, I was placed on the team of regulators and other experts responding to the Aliso Canyon gas leak. I am one of 3 senior oil and gas engineer safety team leads overseeing the comprehensive safety review and testing process. Because much of this material is complicated, or in case people cannot attend the public meetings in person, we are recording and posting the presentation on our website. I will be detailing the state's comprehensive safety review at Aliso Canyon. This extensive series of inspections and tests are designed to ensure that public safety and environmental protection standards are achieved before the state decides whether to allow Southern California Gas to use any of its wells to put natural gas back into the storage field. Safety at Aliso Canyon and all gas storage facilities in California is a key part of the Department of Conservation's renewal plan to put public and environmental health first. We don't want an Aliso Canyon-like situation to occur in the future. It's important to point out that a decision about whether gas injection can resume will not occur until a public meeting is held and people have an opportunity to comment on the findings of our comprehensive safety review. Those findings, including all of the test results at each well and this webcast, can be accessed from our website homepage, www.conservation.ca.gov. There are 2 public meetings scheduled for the evenings of February 1st and 2nd. You can find out more about these meetings by clicking on a link located on our website. We have a companion presentation which will give you additional details about the public meetings. After the public meetings, DOGGR and the California Public Utilities Commission, CPUC, will work together and make a joint announcement as to whether injection at Aliso Canyon can resume. DOGGR Safety Review incorporates elements of 3 different state directives stemming from the leak: Governor Brown's Emergency Proclamation of January 6, 2016, Senate Bill 380, and the State Oil and Gas Supervisor's Order 1109. The main element of that safety review is a rigorous battery of tests, which I am going to talk about. They incorporate some of the best practices and technologies available. DOGGR's most experienced engineers and geologists collaborated with independent experts from the Lawrence Berkeley, Lawrence Livermore, and Sandia National Laboratories to design the review and testing regime. This collaboration started in November 2015, shortly after the leak was reported. When the leak was reported, I was immediately dispatched to the site along with my colleague, Scott McGurk. Since then, we have continually rotated 3 teams of engineers and experts on site, including during major holidays. We set up a field office on site so we could be integrated into real-time decision-making, oversight, and inspections. We helped develop engineering solutions to stop the leak, approved all actions taken by Southern California Gas and its contractors, and reviewed all relevant testing and data. Here we have a typical well design used to withdraw natural gas. Because of the Aliso Canyon gas leaks, DOGGR new regulations require several layers of protection that were not available before. New regulations ensure that there will be no single point of failure in a well. This means extra precautions have been put in place on every well at the Aliso Canyon Storage Facility. On this diagram, you'll see production casing labeled here, and that is like the drinking straw that penetrates the top of your drink if you had a cup with a lid on it. And here you see the packer set in the reservoir cap rock. This keeps the pressure off of the production casing, as production and withdrawal and injection will only occur through the tubing. So DOGGR will be limiting gas injection to the well's inner steel pipe called the production tubing. Injections through the steel pipe casing will no longer be allowed. This means that production casing will not be subject to that reservoir pressure. In order for a well to be approved to return to service, Southern California Gas must conduct a series of 6 rigorous diagnostic tests. Those testing results are reviewed and validated by Dogger engineers, including myself. The 6 tests were divided into 2 batteries. Battery 1 test consists of noise and temperature logs. The first set is essentially an initial diagnostic. These logs can be run very quickly, taking 2 to 6 hours per well, depending on the depth of the well. No drilling or pulling rig is required to run them, only a wireline truck. These trucks can be deployed very quickly in a matter of hours. And these logs were run as a screening criteria to determine very quickly if there were other damaged wells which needed immediate attention. We did not find any. The temperature log is run from the top of the well to the bottom of the well. It's basically a thermometer at the end of a wire that's lowered into the well. Temperature should increase as you go deeper. The earth is warm and the increase is relatively uniform. So we are looking for cooling events or other temperature anomalies. When gas escapes from a container, it cools the surrounding area. Your refrigerator and car air conditioning work based on this principle. Another reason for a temperature anomaly could be the movement of water, either because of shallow groundwater or water flood. The noise log is run from the bottom of the well back to surface. It's a very sensitive microphone and can pick up the tapping of a hammer or other surface noise from several hundred feet down in the well. Gas escaping from a vessel or chamber usually makes a high frequency sound, similar to a small hole in a tire after it's been punctured by a nail. The noise log will record that sound, which I will show you shortly. So here we have an example of a passing noise and temperature log. This is an actual test result from an Aliso Canyon well, standard Cessnon 13. So if you look at this, you'll see these numbers here represent the depth of the well. This green line here is a recording of the temperature of the well. And as you can see, as you go deeper, the temperature is increasing. And these curves here represent the noise. Here is an example of a failing noise and temperature log. This is an actual test result from Aliso Canyon well, Cessnon P6. And again, here's a representation of the depth of the well. Here is a representation of the temperature of the well at that particular depth. And in this area is the cooling anomaly. In this situation, it was a leaking mandrel that was a part of the equipment in the production tubing. This is a reaction of the noise curves, and as you can see at this point, there is a reaction here. A cement bond log test uses ultrasonic sound to evaluate the quality and location of cement on the outside of the casing. Dogger requires at least 100 feet of bonded cement above the gas reservoir for a passing test. Low amplitude readings indicate bonded cement, while higher amplitude readings indicate poor bonding or lack of cement. And this is the first test of the second battery of tests. So here is an example of a cement bond log run on Aliso well Porter 35 that does not indicate any concerns. And again, you can see these numbers here represent the depth of the well, and this is a presentation on the recording of the cement bond log. This is the scale 0 to 20, and this is the scale 0 to 100 for the red line. And what you'll see here is we have good bonding with a recording of about 4 millivolts, which is well below the maximum accepted amplitude. So here's an example of a cement bond log run on Aliso well Mission Adrian 3 that indicates a possible concern. Due to these test results, Mission Adrian 3 was plugged with cement. And again, here is the indication of depth of the well. You have the same scale on the bottom, and you can see on this well the recording is about 50 millivolts. And you'll notice over in this track, this is what we call a railroad track pattern. So there's nothing for the sound to react to. The next battery 2 test was a multi-arm caliper log. And as you can see on the tool here are many fingers, arms, that are part of this tool. Each of the arms records what it's going against on the production casing. So this only inspects the inside of the casing and is used to detect corrosion damage and or other geometric irregularities. So this is an example of a caliper log that passed from well Aliso Porter 35. And so you can see the arms and fingers of the caliper detect the internal diameter of the well, or ID. And that's represented by all these tracks on the right side. What you want to notice here is this signature shows a connection between two joints of pipe in the well. And so this is normal. This is an example of a caliper log failure from Aliso well Porter 44. All fingers of the caliper reacted to this failure in the casing, as you can see by this diagram. And on this side, you'll see a representation of the minimum ID and the maximum ID, internal diameter, and you could see the damage is represented by this signature here. So this is severe damage. As a result of these tests, well, Porter 44 was repaired with a new segment of pipe cemented across this section of the well. The next battery 2 test was the ultrasonic casing inspection log. It uses ultrasonic technology to examine the casing thickness and cement bond quality. It can detect casing damage on the outside of the pipe, and this data can be used to calculate the wall thickness and subsequently an equivalent burst pressure rating using a formula called Barlow's equation. Here is an example of a passing ultrasonic casing inspection test on Aliso well Porter 69C. The second track here shows good pipe as the blue minimum and the red maximum curves are very smooth. The other tracks here are just representations of the acoustic impedance. So here's an example of an ultrasonic failure from Aliso well Porter 44, which was the same well that had the failed caliper test on previous slides. It's important to note that this was not another issue in Porter 44, just another test that caught the same issue. You'll also remember that Porter 44 was repaired as a result of these tests. So this is the same failure point as seen on the caliper log, and you can compare the reactions of the different tools and technologies. And as you can see in the blue and red curves here, they go off scale, indicating there are serious damage in this interval. The next battery 2 test is the magnetic flux leakage. This tool uses magnetic flux technology to examine the inside and outside of the casing. The tool magnetizes the steel and then measures leakage in areas of corrosion or missing metal. It's also run on a wire line. It can also detect metal loss on the outside of the pipe. This data can then be used to calculate wall thickness and subsequently an equivalent burst rating using the same formula called Barlow's equation. The picture is representative of an example of metal loss on the outside of a casing joint, but this is not from Aliso Canyon. It's only for illustrative purposes. So here is an example of a passing magnetic flux test from Aliso well Porter 69C from the interval 2050 to 2100 feet. So this section is free of anomalies. Again, notice the reaction of the tool here in the area of the connection between the two pipes. So this is where there's a change in the mass of metal, and that's why you have this reaction that the tool is detecting. So here's an example of a failing magnetic flux test. This is the same failed area of well Porter 44, which we saw in previous slides. Again, this is not another failure, it's just another test that detected the same failure in well Porter 44. And so you can see why these tests are so important. These tests can ensure that wells are safe. Remember, this well has been repaired and is now in a safe condition. And again, so notice the reaction in the area of the joints where they're connected here. And then this is the damaged area, and you can see its signature here. And lastly, we have another level of testing is done through pressure tests. The production casing and tubing must be tested to at least 115% of the maximum operating pressure, which is 3,625 psi, or pounds per square inch. This is done with a test packer and fluid. Once the production tubing and packer are installed, the equipment is again tested to 1,000 psi to ensure the packer is properly set. Completion fluid is used as it is incompressible versus a gas, which is highly compressible. Tests are for 1 hour and recorded and witnessed by a Dogger engineer. A passing pressure test is one which has a change of less than 10% for any 30-minute period during the hour-long test. And this is to account for the fact that there are minor amounts of air in the system and other environmental factors. Here's a passing casing pressure test example. On a test of over 3,600 psi, we have a slight change at the beginning of the test and then a period of stability with an overall change of only 1.6% or 58 psi. Here is a hypothetical example of a casing pressure test failure. In actual testing, if you get to the test and you wouldn't usually record this, you would just transition into an investigation and repair mode. But I just wanted to show you what a failing test would look like. Currently, there are 34 wells that have passed all 6 tests, both batteries. 1 well is in transition and undergoing testing. The remaining 79 wells at Aliso have been safely taken out of operation and isolated from the storage reservoir. How have they been isolated safely? Well, first they had a noise temp log run to ensure that there are no unexplained anomalies. A bridge plug is then set towards the bottom of the well, and the well is filled with water. The bridge plug acts as sort of a cap on a soda bottle. This plug can contain upwards of 8,000 psi of pressure. And remember, the maximum allowable reservoir pressure in this field is 2943 psi. In addition, there will be upwards of 3,500 psi of water pressure from the fluid on top of the plug. So this is like having a ton of bricks on top of that bottle cap. There is also a witnessed pressure test conducted to ensure that there are no leaks and the equipment is properly set. The production casing cement job is also reviewed to ensure the packer or bridge plug is set in a competent area of the pipe. Wells in this category have 1 year to be further tested and complete the second battery or permanently sealed. When testing happens, a working rig is put on the well, which also serves as a safety measure against leaks and blowouts. Lastly, a real-time pressure monitoring system has been installed on every well. As part of our safety review, we set recommended minimum and maximum pressure thresholds for Aliso Canyon. As yet another level of safety, our recommended limits are well below the actual capacity Aliso could handle and lower than the levels requested by Southern California Gas. Dogger consulted with the national laboratories when determining these pressure limits. You can find out more about these recommendations on our website. The status of all 114 wells in the Aliso field and their testing results can be found on our website, www.conservation.ca.gov. On our homepage, you'll find a link to the Aliso Canyon test page, which has the test results and a report on the rest of the elements in our comprehensive safety review. We also have a GIS feature that shows the locations of the wells in the field. You can also just Google Aliso Canyon test results. And here is just a picture of the Aliso Canyon test results by well. These are all hyperlinks you can test, you can click on and see the test results. Dogger is now accepting comments from the public on the comprehensive safety review. You could submit your comments at the public meetings on February 1st or 2nd in Woodland Hills, or in writing to alisocomments@conservation.ca.gov, by fax or regular mail. Public comments will be accepted until 5 p.m. Monday, February 6th. This concludes my overview of Dogger's comprehensive safety review test at the Aliso Canyon storage field. Again, I want to note that a decision about whether injection of gas into the storage field can resume will not occur until a public meeting is held and people have an opportunity to comment on the findings of the comprehensive safety review. Thank you for taking the time to watch this presentation, and we look forward to hearing from you.